46 years of silence. 24 billion kilometers from home. The furthest object ever built by human hands has started to scream. But it's not a cry for help. It's a message, in a language we never taught it. November 2023. The code changed. And the mystery began. 24 billion kilometers from Earth, there is a witness that has been speaking to us for nearly half a century. It is a lonely, fragile assembly of aluminum and plutonium, moving through the absolute cold of interstellar space at 61,000 kilometers per hour. For 46 years, its voice was predictable. A steady stream of telemetry, a heartbeat of data points representing magnetic fields, plasma densities, and the faint whispers of distant stars. But on November 14, 2023, the witness stopped making sense. The Deep Space Network, a global array of giant radio antennas, captured the signal as usual. The carrier wave was strong, the frequency was correct, but the content had mutated. Instead of the familiar packets of scientific data and engineering diagnostics, Voyager-1 began transmitting a repetitive, unwavering pattern of ones and zeros. It was a binary stutter. A digital loop that felt less like a mechanical failure and more like a conscious mind trapped in a recursive thought. In the control rooms of the Jet Propulsion Laboratory, the initial assessment was grim. This was not the chaotic noise of a failing transmitter or the distorted hiss of cosmic interference. This was structured. The spacecraft was still processing logic, but the logic had become circular. It was sending a message that no system on Earth could decode because the message itself had no destination. The most distant human-made object in existence had suddenly become a locked room, and we were standing outside the door, holding a key that no longer fit the lock. To understand the gravity of this anomaly, one must look at the architecture of the witness. Voyager-1 does not think like a modern machine. Its brain, the flight data system, is a relic of 1970s engineering, a masterpiece of minimalist computing where every single bit of memory is a precious resource. It operates on a scale of kilobytes, not gigabytes. There are no redundant cloud backups, no remote desktop protocols. There is only the long, agonizing silence of the void, punctuated by a signal that takes 22.5 hours to travel one way. The investigation did not begin with a repair. It began with a forensic reconstruction of a ghost. The engineers had to ask, what could cause a logical system to abandon its programming while maintaining its pulse? The power levels were stable. The thermal signatures were within limits. The orientation was perfect. Yet, the data was a desert of repetition. We were looking at a digital crime scene where the evidence was hidden inside a stream of binary code that seemed to lead nowhere. The obvious explanation would be a total hardware collapse, a terminal failure of the central processor after decades of radiation exposure. But in the world of the event weaver, the obvious explanation is rarely the final verdict. If the processor had died, the signal would have vanished or turned into true white noise. The presence of a structured, repeating pattern suggested that the machine was still trying to fulfill its mission. It was trying to tell us something about its own internal state, but the bridge between its memory and its voice had been severed. We were no longer just observers of a space mission. We were investigators of a cosmic amnesia. The first clue lay in the specific rhythm of the binary loop. It wasn't random. It was a reflection of a broken cycle. Somewhere, deep within the flight data system, a single command was being executed over and over again, unable to move to the next step. To find the source of this stutter, the team at JPL would have to perform the most distant diagnostic in human history, reaching across the solar system to touch a mind that was slowly losing its grip on reality. The search for the broken link began with a gamble. In March 2024, the investigation shifted from passive observation to active interrogation. The engineers at the Jet Propulsion Laboratory crafted a specific command sequence designed to bypass the normal operating software and force the flight data system to reveal its entire internal memory map. It was a digital autopsy performed on a living patient. We waited 45 hours for the results to return from the edge of the heliosphere. When the data finally arrived, it wasn't the usual binary stutter. It was a massive, raw dump of the machine's entire cognitive state. Embedded within this sea of information was the second major clue. A single engineer, comparing the new readout with the original 1970s blueprints, noticed a discrepancy. About 3% of the memory was corrupted. One single chip, responsible for storing a portion of the FDS software code, had ceased to function. In a modern computer, such a loss would be trivial, handled by error correction algorithms or bypassed by redundant hardware. But for Voyager-1, this chip was a vital piece of its fundamental logic. Without it, the machine was like a narrator who had lost the middle of a sentence. It kept returning to the beginning, unable to find the words to continue. The investigative question then shifted from what happened to why now. The environment of interstellar space is not empty, it is a high-energy shooting gallery. For 46 years, the spacecraft has been bombarded by cosmic rays, heavy ions and protons traveling at near light speeds. These particles can penetrate the shielding of the spacecraft, striking a single transistor and flipping its state from a 1 to a 0. This is a bit flip. Normally, these are isolated incidents. But after nearly 5 decades, the cumulative degradation of the hardware reaches a tipping point. The hardware had simply reached its physical limit. The silicon was tired. This was the point of no return. We could not go to the spacecraft to replace the chip. No human vessel can catch up to Voyager-1, and no robotic mission could reach it in time to save its mission. The investigation faced a paradox. The witness was still alive, but its brain was physically broken. To save the mission, the team had to perform a feat of software engineering that defied the original design of the machine. They had to take the instructions that lived on the dead chip, break them into smaller fragments, and hide those fragments in the tiny gaps of healthy memory scattered across the rest of the system. It was a puzzle of extreme constraints. They were operating with less memory than is found in a modern car key. Each fragment of code had to be meticulously adjusted to ensure that, when executed, the different parts could still find each other and function as a unified whole. If a single pointer was off by 1 byte, the entire system would crash, and the most distant emissary of humanity would be silenced forever. The engineers spent weeks simulating the move on Earth, using aging hardware and ancient documentation to predict how the machine would react to having its soul relocated. On April 18, 2024, the command was sent. It was a surgical strike across the void. The instruction was to move the specific code responsible for packaging engineering data to a new address in the memory. For the next 2 days, the silence from the stars was absolute. The team waited, knowing that if they had made even a minor miscalculation, Voyager-1 would never speak again. It was the ultimate test of the causal chain we had built. If our understanding of the corruption was correct, the machine would recover. If we were wrong, the void would claim the witness. On April 20, the signal reached the Goldstone antenna in California. The binary stutter was gone. In its place was a clean, perfect stream of engineering telemetry. The witness was back. It was reporting on its health, its temperature, and its status for the first time in 5 months. The code from the void was not an alien message or a terminal failure. It was a symptom of a machine struggling to survive in an environment it was never truly built to endure for so long. The investigation had succeeded, but the victory brought a new, more profound realization about the nature of our deep space messengers. The evidence is mounting. Join the investigation to find out the final verdict. Subscribe to the channel to stay updated. The restoration of the engineering data was only the first phase of the recovery. The investigation now turned to the more complex layer of the machine's consciousness, the science data. While the telemetry told us that the spacecraft was physically healthy, the instruments, the cosmic ray detectors, the magnetometer, and the plasma wave system were still trapped behind the wall of the damaged memory chip. To unlock them, the team had to expand their surgical operation. This was not a simple matter of copying files, it was an act of digital redistribution. They had to weave the remaining mission-critical functions into the narrow, functional corridors of the flight data system, ensuring that no two pieces of code occupied the same physical address. It was a high-stakes game of memory management played out over a 45-hour round-trip communication delay. By mid-May, the reconstruction was nearly complete. The final sections of the science packaging code were relocated and verified. When the next transmission arrived, the result was a revelation. The data wasn't just back, it was pristine. This allowed the investigators to look closely at the environment through the eyes of the veteran explorer. What they found was a continuation of the mystery that began when Voyager-1 first crossed the heliopause in 2012. The magnetic field readings and the density of the interstellar medium showed that the spacecraft was moving through a region of space that is increasingly turbulent. We are no longer observing the smooth exit from the Sun's influence, we are observing the interaction between our star's waning breath and the raw, unshielded pressure of the galaxy. The third clue in our investigation emerged from a comparison with the twin witness, Voyager-2. Although Voyager-2 is younger and follows a different trajectory, it serves as a vital control group in this cosmic experiment. It has not yet suffered the same catastrophic memory failure, but it is exhibiting its own signs of exhaustion. The power levels on both craft are dropping by about 4 watts per year as the plutonium-238 in their radioisotope thermoelectric generators decays. This creates a secondary pressure on the mission. The investigators are not just fighting the degradation of hardware, but the slow dimming of the lights. Every command sent to fix a software glitch must be weighed against the dwindling energy budget required to keep the heaters running and the antennas pointed toward the pale blue dot. This comparison revealed a pattern of interstellar weathering. The anomaly of the code from the void was not an isolated event but a predictable consequence of the long-term exposure to the vacuum. The vacuum of space is often portrayed as an empty nothingness, but to a machine, it is a corrosive medium. Thermal cycling, radiation-induced lattice defects in the silicon, and the slow sublimation of materials all contribute to a state of mechanical and digital fatigue. Voyager-1 stutter was the first clear evidence that the barrier to interstellar travel is not just distance or time, but the structural integrity of information itself. The witness was not just losing its voice, it was losing its ability to maintain its own identity against the entropy of the universe. As the team at the Jet Propulsion Laboratory continued to refine the new memory map, they realized they had created a digital chimera. Voyager-1 was no longer the machine that launched from Cape Canaveral in 1977. It was now running a unique, hand-stitched version of its operating system, a version that exists nowhere else in the universe. This ad hoc architecture is a testament to the ingenuity of the investigators, but it also marks a transition in the mission. We have moved from the era of exploration to the era of preservation. Every bit of data we receive now is a bonus, a fragment of truth salvaged from a machine that, by all laws of engineering, should have been silent decades ago. The investigation into the code from the void had revealed the ultimate vulnerability of our most distant messenger. It is a finite object attempting to measure an infinite frontier. The fourth stage of our investigation focuses on the strategic consequences of this digital survival. By successfully relocating the flight data system's logic, the team didn't just fix a bug, they effectively performed a brain transplant on a machine moving at 17 kilometers per second. This success has changed the fundamental calculus of the mission. For decades, the primary threat to Voyager was considered to be its dwindling power supply, the slow, radioactive decay of its plutonium heart. But the code from the void incident proved that the digital mind might fail before the physical body. We are now monitoring a phenomenon called software aging. In the extreme environment beyond the heliopause, the very bits that define the mission's purpose are subject to the same erosion as the metal and plastic of the hull. This realization has forced a new protocol for interstellar observation. Every signal now received from Voyager-1 is treated as a potential forensic data point. If the machine begins to stutter again, the investigators will not look for an external cause, they will look for the next ship to fail. There is a profound irony in the fact that our most advanced understanding of the interstellar medium is being transmitted through hardware that is increasingly reliant on patches and workarounds devised by engineers who, in many cases, were not even born when the spacecraft launched. The investigation has revealed a generational chain of knowledge, where the secrets of 1970s assembly language must be preserved to understand the 1920s reality of the deep cosmos. Furthermore, the recovery effort has provided a blueprint for how we might manage future interstellar probes. If a single bit flip can derail a mission, then future craft must be designed with fluid intelligence, the ability to autonomously reconfigure their own internal logic when physical components fail. Voyager-1, in its struggle to speak, has become the unwitting prototype for the self-healing machines of the future. The data it sends back now carries a double meaning. It tells us about the magnetic fields of the galaxy, and it tells us about the limits of human-made information in the face of deep time. We are watching the slow transformation of an active explorer into a drifting monument, a transition that is happening one corrupted byte at a time. The investigation into the anomaly also uncovered a strange stability in the wake of the repair. Since the relocation of the code, the error rates in the FDS have actually decreased. By moving the software to a less utilized portion of the memory, the engineers may have inadvertently placed the machine's consciousness into a cleaner, less damaged sector of the silicon. This suggests that the void is not uniformly hostile, the damage is localized, accidental, and perhaps avoidable with enough foresight. The code from the void was not a message from an external intelligence, but it was a message from the machine itself, a warning that the greatest distance we have to overcome is not the space between stars, but the durability of the record we send across it. As Voyager-1 continues its journey, the focus shifts to the final horizon. The spacecraft is currently moving through the very local interstellar medium, a region where the sun's influence is almost non-existent. The data we are gathering now is the most pure information we have ever collected about our place in the Milky Way. But the clock is ticking. Within the next decade, the power will drop to a level where the science instruments must be turned off one by one, until only the transmitter remains, sending a carrier wave that carries no data at all. The investigation of the glitch was a battle to delay that silence. It was a fight to ensure that when the witness finally goes dark, it does so with its memory intact, having told us everything it could about the edge of the world. The investigation into the anomaly of Voyager-1 concludes not with the discovery of an external force, but with a profound insight into the nature of our own creations. The code from the void was the ultimate witness's testimony to its own mortality. We have learned that the silicon brain of the spacecraft is as susceptible to the ravages of time and radiation as a human mind is to age. The successful repair was not merely a technical triumph, it was a resynchronization of humanity with its most distant outpost. By redistributing the damaged logic, we have extended the life of the mission, but we have also accepted a new reality. Voyager-1 is no longer a static machine, but a shifting, evolving entity that requires constant digital guardianship from a planet it left behind nearly half a century ago. The structural conclusion of this case is clear. The anomaly was a physical failure manifested as a logical loop, a digital stroke caused by the relentless bombardment of cosmic particles. Our intervention proved that distance is not an absolute barrier to human ingenuity, but the event serves as a terminal warning. We are reaching the limits of 1970s technology in a 21st century interstellar environment. The witness is still speaking, but it is now living on borrowed time and relocated memory. The causal chain is complete, from the first binary stutter to the forensic memory dump, and finally to the successful relocation of the spacecraft's soul. We have mapped the anatomy of a cosmic glitch. Yet, as the event weaver connects these points, a larger shadow falls over the investigation. Voyager-1 has shown us that information can be preserved even when the hardware fails, but it has also highlighted a haunting vulnerability. If a single bit flip can nearly silence the most important mission in history, what does this say about the permanence of our presence in the galaxy? We are sending our history, our music, and our coordinates into a medium that systematically erodes the very tools required to read them. The code from the void was a brief glimpse into a future where our messengers continue to drift, but the messages they carry become unreadable loops of meaningless data. The final verdict is a paradox of success. We have restored the voice of Voyager-1, allowing it to continue its silent trek through the interstellar dark. It will continue to measure the plasma and the fields, sending back data that will redefine our understanding of the heliosphere's edge. But the investigation remains open. We have fixed the mind, but we cannot stop the dimming of the heart. The power is fading. The cold is deepening. Every bit of data we receive now is a precious fragment of a dying conversation, a last will and testament from the edge of the solar system. This brings us to the ultimate open loop. Voyager-1 is currently our only active sensor in the true interstellar medium, but it is not the only mystery waiting in the dark. While we fight to keep this ancient machine alive, other witnesses have already gone silent or, in some cases, disappeared entirely without a binary stutter to warn us. If a machine as robust as Voyager can be brought to the brink by a single particle, what happened to the celestial objects that were once there and now are gone? The evidence of Voyager's survival gives us hope, but it also forces us to look closer at the stars that didn't just malfunction, they vanished. The investigation into the code from the void is closed. But the search for the missing pieces of our cosmic map is only beginning. The next sequence of events takes us away from the edge of our system and toward the deeper reaches of the galaxy, where the project known as Vasco has identified a different kind of anomaly, stars that were captured on film for decades, only to disappear into the nothingness without a trace. The Weaver's work is never finished. Join the investigation to find out the final verdict. Subscribe to the channel to stay updated.